So hello friends, I am Swastik and I have started a YouTube channel and this is the first video. So today in this video we are going to study lesson number 1 of mathematics of class 9 number system. So in number system we have already studied this much part and we have to study irrational numbers. So in number system the first one is whole numbers which we detonate from W. So whole numbers are detonated from W. The examples of whole numbers, these are the whole numbers. Now comes the natural number. We detonate natural number with the symbol N. Here are the natural numbers. So there is only one difference between whole numbers and natural numbers, that whole numbers have 0 and natural numbers does not have 0, except they both are same. Now comes the integers. We detonate integers with the symbol Z. Now here's a representation on number line of integers. So on number line there are two sides, left and right. Left side is of negative numbers, right side is of positive numbers. So what about 0? 0 is neither positive neither negative, it's neutral. So all the negative numbers and all the positive numbers, they are called integers. Here I'll write they are infinite from both the sides. Now we will come to that topic, but before that I would like to discuss something also. Can we say that all the whole numbers are natural numbers? Let's see. I am saying that all the whole numbers are natural numbers, but 0 does not come in natural number. So all the whole numbers are not natural numbers. But can we say that all the natural numbers are whole numbers? Yes, because natural numbers start from 1 and are infinite. Whole numbers start from 0 and are infinite, and after 0 comes 1. So all natural numbers are whole numbers. We can say that. Now integers. Can we say that all the integers are whole numbers? So now I am saying whole numbers, that means whole and natural both, because natural numbers are whole numbers. So can we say that integers are whole numbers? No, because integers have a negative side and whole numbers does not have a negative side. So all the integers are not whole numbers. But can we say that all the whole numbers are integers? Yes, because whole numbers start from 0 and infinite, and the positive side of integers starts from 1 and is infinite. But there is also 0, it's neutral but is there. So we can say that all the natural numbers are whole numbers. All the whole numbers are integers, but not all the whole numbers are natural numbers, and not all the integers are whole numbers. So now let's move on to real numbers. Real numbers are of two types, rational numbers and irrational numbers. Actually, real numbers, all these numbers are combined and then real numbers are formed. Means group of all numbers is real numbers. But here I'm just going to say that real numbers are divided in two types, real, rational and irrational. We detonate rational number with the symbol Q. Now rational numbers are numerator upon denominator and upon D. So here are the examples. 3 upon 4. Here 3 is numerator and 4 is denominator. It's example number 1. Another example, 8 upon 1. So now by referring these two examples, can we say that all the whole numbers are rational numbers? Can we say that all the whole numbers are rational numbers? Or else we can also say that all the integers are rational numbers. Let me go back to them. All natural numbers are whole numbers. Or here, all natural numbers are whole numbers. All whole numbers are integers, and all integers are rational numbers, means real numbers. Real numbers are divided into two types, rational and irrational. So the numbers which are rational are obviously real numbers. So we can say that natural numbers, all the natural numbers are whole numbers, all the whole numbers are integers, and all the integers are real numbers. So now about this, that I told you that all the integers are real rational numbers. But what is the proof to that? Because in integers we are saying -2, -1, 0, 1, 2, infinite. But rational number are n upon d, and here there is only n. D is not here. So how can integer be rational number? I'll tell you one more thing, that any number which does not have a denominator can be written as n upon d. Let's take an example of -2. -2 here does not have a denominator. So we can write -2 as -2 upon 1, and here it's n upon d. So this and this. So in short we can say that integers are rational numbers. So now irrational numbers. I hope that you have understood the previous topics. So now irrational numbers. Irrational numbers are numbers, let's say here is our division box. Now in here comes the quotient, and here is the remainder. But we are only talking about the quotient. Now in the quotient, if the number is repeating 0.24, 244 and 2444, here 4 is repeating in the quotient. So now we will write it as 0.24, 244, 2444. Here 4 is repeating, so the numbers irrational. What are irrational numbers? Irrational numbers are numbers which are endless. Means in a quotient, if we get this, then it's irrational. But what irrational? It's a non-terminating irrational. Yeah, irrational are also divided into two types, terminating and non-terminating. So these are non-terminating. Sorry for the interruption, but irrational are two types, terminating and non-terminating. So this are non-terminating. Now what about terminating? This terminating, we can get an instinct from the name that non-terminating. Terminating is like an, let's give a simple term, ending. So here terminating is ending and non-terminating means not ending. So this is a not ending number because 4 is continuously repeating and is not going to end. But terminating number is going to end. So here 0.244, it's a terminating number because 244, after 244 we get remainder 0. That means 244 is a terminating number. And in the numbers here, if if we have 3, and after 4 calculation we have 2.44 here number, and then again comes 3 in the remainder, and then we are going to repeat all this whole process again here, and that will be 2.44444. Let me repeat it again with another example. Here is, let's take 4. Now here we will get let me take a simple one, 0.222. So what? Here we will divide 4 with let's see any number, and in the number in which we get remainder of 2. And if the number here cannot be divided with 2, then again we will take a 0 here. We will take a 0 here. So now here again comes 4, and when the 4 again comes in the remainder and we have to repeat all the same process again, then that number is a non-terminating number. So I hope you have understood what a terminating and non-terminating number. Now the very much important thing to know is this: all natural numbers are whole numbers. All whole numbers are integers, and all integers are real numbers. But we cannot do vice versa of this, because all real numbers cannot be integers. Or can they be? Let's see. Integers does not have 0.2444. They have numerator upon denominator form numbers, but they do not have decimal numbers between them. They do not have decimal numbers between them. So integers are not real numbers. Then can we say that the integers are whole numbers? No, we cannot say that all the integers are whole numbers, because -1, -2, I already told that the negative side is not coming in the whole numbers. The whole numbers only have positive side. And we also cannot say all whole numbers natural numbers. All whole numbers natural numbers, because 0 is whole number, and in natural numbers 0 is not coming. So we cannot do vice versa of this. So I hope you have understood this. Now I'm going to take some questions of exercise 1.1 so you can clearly understand this topic.